Welcome back to Kafka Internal's Crashcasts. I'm your host, Sheila, and today we're diving deep into the world of Kafka producers. Specifically, we'll be tackling the crucial topic of error handling and timeouts. Joining me, as always, is our Kafka expert, Victor. Hey, Victor, ready to unravel some Kafka mysteries?
Hello, Sheila. Absolutely, I'm excited to dig into this important aspect of Kafka producers. Error handling and timeouts are critical for building robust and reliable Kafka-based systems.
Great! Before we jump in, let's quickly recap where we are in our journey. We're in the second level of our series, Jedi Knight Operational Proficiency, and we're exploring the depths of Kafka producers. We've already covered producer configurations, performance impacts, serializers, partitions, and keys. Now, we're ready to tackle the challenges that arise when things don't go as planned.
That's right, Sheila. Understanding how to handle errors and manage timeouts is crucial for any Kafka developer or operator. It's what separates a robust, production-ready system from one that fails under pressure.
Absolutely. And to get our listeners' gears turning, I've got a quiz question for them. Here it goes. In a Kafka producer, what happens if a message fails to be sent due to a network issue and the retry's configuration is set to 0? Victor, any thoughts on this question?
Ooh, that's a great question, Sheila. It really gets to the heart of error handling in Kafka producers. Without giving away the answer, I'd say it touches on the interplay between network issues, configuration settings, and how Kafka producers behave in less than ideal circumstances. Listeners, keep this question in mind as we dive into our topic today.
Perfect setup, Victor. Now, before we dive deeper, could you give us a quick overview of the types of errors we might encounter when working with Kafka producers?
Certainly, Sheila. Broadly speaking, we can categorize errors into two main types: retryable and non-retryable errors. Retryable errors are temporary issues that might resolve themselves if we try again, like network timeouts or leader not available errors. Non-retryable errors, on the other hand, are more permanent and won't be resolved by retrying, such as message too large errors or authentication failures.
That's a helpful distinction, Victor. So, when we talk about error handling, we're primarily concerned with how to deal with these different types of errors, right? How does Kafka approach this?
Exactly, Sheila. Kafka provides several mechanisms for handling these errors. One of the primary tools is the retry mechanism. When a retryable error occurs, Kafka can automatically retry sending the message based on the configuration we set. This is where the retry's configuration comes into play, which we hinted at in our quiz question.
Interesting. So, if I understand correctly, setting retries to a value greater than 0 would allow Kafka to attempt resending a message if it encounters a retryable error. But what about timeouts? How do they factor into this?
Great question. Timeouts are crucial in error handling and are closely related to retries. Kafka producers have two main timeout configurations: request timeout.ms and delivery timeout.ms. The request timeout.ms determines how long the producer will wait for a response from the broker for a single request. If this time is exceeded, the producer will either retry the request, if retries are configured, or consider it a failure. The delivery.timeout.ms, on the other hand, is the maximum amount of time the producer will spend on retrying and waiting for a successful response from the broker, starting from when the record is first sent. This includes all retry attempts.
That's fascinating, Victor. It sounds like there's a delicate balance to strike between allowing enough time for retries and not letting operations hang indefinitely. Can you give us an analogy to help visualize this?
Absolutely, Sheila. Think of the Kafka producer as a postal service, and each message as a package. The request.timeout.ms is like the time a postal worker waits at your door for you to answer and accept the package. If you don't answer in time, they might try again later, retry. The delivery.timeout.ms is more like the overall time the postal service allows for delivering your package, including all attempts. If they can't deliver it within this time, they'll return it to the sender or consider it undeliverable.
That's a great analogy, Victor. It really helps to visualize the process. Now, I'm curious about how developers can gain more control over error handling. Are there any advanced techniques they should be aware of?
Indeed there are, Sheila. One powerful technique is using callbacks. When sending a message, developers can provide a callback function that will be executed when the send operation completes, whether successfully or not. This allows for custom error handling logic, such as logging specific errors, triggering alerts, or implementing custom retry logic.
That sounds really useful, Victor. It reminds me of exception handling in other programming contexts. How does this compare to error handling in other messaging systems?
Good observation, Sheila. While the concept of callbacks for error handling is common in many messaging systems, Kafka's approach is particularly robust due to its strong ordering guarantees and the ability to configure retries at a global level. For example, compared to RabbitMQ, Kafka's producer has more fine-grained control over retries and delivery guarantees. In RabbitMQ, you often handle retries at the application level, whereas Kafka builds this functionality into the producer itself.
That's a helpful comparison, Victor. Now, you mentioned something earlier about idempotence. How does that fit into the error handling picture?
Excellent question, Sheila. Idempotence is a crucial concept in Kafka error handling. An idempotent producer ensures that retrying a message doesn't result in duplicate entries in the Kafka topic. When you enable idempotence by setting enable.idempotence to true, Kafka assigns each batch of messages a sequence number. If a batch fails and is retried, the broker can use this sequence number to detect and prevent duplicates. This is particularly important in scenarios where you might encounter network issues or broker failures, as it ensures that your data remains consistent even in the face of retries and errors.
Wow, that's a powerful feature. It seems like it could save developers a lot of headaches. Are there any common pitfalls or misunderstandings about error handling and timeouts that our listeners should be aware of?
Definitely, Sheila. One common misunderstanding is assuming that setting a high number of retries will solve all problems. While retries are useful, they're not a silver bullet. It's crucial to understand the nature of the errors you're encountering and address root causes where possible. Another pitfall is neglecting to properly configure timeouts. If delivery.timeout.ms is set too low relative to request.timeout.ms and the number of retries, you might find that messages fail before all retry attempts are exhausted. Lastly, some developers overlook the importance of monitoring and alerting on producer errors. Regular monitoring can help identify recurring issues and potential bottlenecks in your Kafka setup.
Those are great points, Victor. It really underscores the importance of understanding these concepts thoroughly. Now, before we wrap up, let's revisit our quiz question. Can you reveal the answer?
Of course, Sheila. The quiz question asked what happens if a message fails to be sent due to a network issue when retries is set to 0. In this case, the producer will immediately consider the send operation a failure. It won't attempt to resend the message, and the error will be returned to the application, either through the future returned by the send method or via the callback if one was provided. This underscores the importance of carefully considering your retry settings in production environments.
Thank you, Victor. That really ties together a lot of what we've discussed today. To summarize the key points: 1. Kafka errors can be categorized as retryable or non-retryable. 2. Proper configuration of retries and timeouts is crucial for robust error handling. 3. Callbacks provide a powerful mechanism for custom error handling. 4. Idempotent producers help prevent duplicates when retrying messages. 5. Monitoring and understanding the nature of errors is key to maintaining a healthy Kafka system. Victor, any final thoughts or tips for our listeners?
Absolutely, Sheila. I'd encourage our listeners to really dive into their Kafka producer configurations and experiment with different settings in a test environment. Understanding how your system behaves under various error conditions can be invaluable when it comes to building robust, production-ready Kafka applications.
Excellent advice, Victor. And that brings us to the end of today's episode on error handling and timeouts in Kafka producers. In our next episode, we'll be moving on to explore Kafka consumers in depth starting with consumer groups and offsets. Listeners, if you've enjoyed this deep dive into Kafka, please subscribe to our podcast and leave us a rating. Your support helps us continue bringing you these in-depth explorations of Kafka internals. Until next time, this is Sheila signing off from Kafka Internals Crashcasts.